In this video, I'm going to talk about an interesting use case or benefit for having 3 route reflectors instead of just 2 route reflectors. So the high-level summary to this is that in some service provider networks, maybe smaller service provider networks, the route reflectors might also be acting as PEs. So if you just have 2 route reflectors, there's actually no redundancy for the routes between the route reflectors for which they're acting as PEs. There's just that one single session and there's no other reflection of routes between the 2 route reflectors. So having 3 route reflectors restores this redundancy in the route reflection mesh. And it's quite useful if you run into situations where like you want to add an address family and you want to tear down the session temporarily. With 2 route reflectors, you are going to cause an outage. With 3 route reflectors, you're not. Um, on this channel, I like to talk about interesting service provider concepts, things that kind of come up through kind of experience of operating service provider networks, and that don't really come up in courses or textbooks or documentation and things like that. And this is a case that I've never actually seen elsewhere, but I kind of came across it and realized, oh, this is actually a very useful solution. So towards the end of this video, I'll get into this particular design more in depth of how this works. I thought it would be interesting to start off talking just about route reflection basics, how route reflection works, and then look at route reflection design considerations like the cluster ID and whether you're pairing between the route reflectors or not. Then we'll go into this scenario in depth. Okay, so typically route reflection, we think of as like this particular design where you've just got these 2 separate route reflectors. All the clients pair to both route reflectors, so you've got this redundancy. And this solves the IBGP full mesh scalability issue, where, without the route reflection, if there was like 100 BGP speakers in an AS, you would need 99 BGP sessions on each router. And if you add a router, now you have to go into all other 100 routers and add that as a neighbor. So, this is obviously very unscalable, and route reflection solves that problem. But it might be interesting to take a step back and say, well, why do we need a full IBGP mesh in the first place? Why can't a router advertise a route lured from one IBGP peer to another IBGP peer? So the reason for this is because BGP's loop prevention mechanism is the AS path attribute. So if a router sees its own AS number in the AS path, of course it drops the route. This is for loop prevention. And this mechanism works on basically the eBGP eBGP sessions. It doesn't work for IBGP because the AS essentially abstracts all routers in one AS into just one system, essentially. These are all AS 100, let's say. So like if router 1 in AS 100 advertises a path out to the internet, and it comes back and router 2 in AS 100 receives it, it's going to drop that because its own AS is in the AS path, even though router 2 actually itself did not advertise that path. So this mechanism is not going to work within the AS for BGP sessions within the AS, so IBGP sessions. So instead, we need some other loop prevention mechanism. And the most simple prevention loop prevention mechanism, is just split horizon. So this you can maybe relate this also to things like VPLS for bum flooding, where instead of like doing some kind of spanning tree loop prevention between all PEs for a VPLS domain, you just say, well, if you receive a bum frame on one pseudo wire, don't flood it out in the other pseudo wires. So as long as there's a full mesh of pseudo wires, all PEs are going to receive that bum frame, and there's not going to be any loops because they're not sending that out any other pseudo wires. So the same concept is with IBGP, where you just set up a full mesh of IBGP sessions, and that allows for loop prevention because the split horizon allows for loop prevention. But as long as you have a full mesh, all BGP speakers in the AS are going to receive that path. So I thought it'd be interesting to take a look at the RFC and some of the language that's around this concept. So this is the current version for BGP version 4. And this is the section that talks about split horizon, where it says a BGP speaker, so when a BGP speaker receives an update from an IBGP peer, it shall not re-advertise that route to another IBGP peer. It doesn't call this split horizon, but we kind of think of this as a split horizon rule. So it's also really interesting to actually to note that this RFC doesn't explicitly mention that you need a full IPGP mesh. And I'll link to an interesting article down below uh, that actually talks about how, well, it makes the argument that a full IPGP mesh is kind of a myth that you need it. That actually, like in a stub network situation, you might be completely fine with not having a full mesh of IPGP sessions, and you don't have any like reachability issues or loop issues or things of that nature. So this concept of needing a full IPG mesh has actually over the years kind of been removed from the RFCs because I've got this RFC from this is all the way back in like 1989 for BGP version 1, and it specifically states that these gateways must have direct BGP sessions with each other. The BGP sessions should form a complete graph. So it says in order to maintain consistent routing information. So this is actually mandating that you do have a full IBGP mesh, but this verbiage has this requirement has been kind of backed out over the years in BGP because it's not. Is it truly a requirement? You know, you can run a BGP network without having a full IBGP mesh. It'll work fine. Um, but we should note that it's really kind of generally accepted that you're going to have a full IBGP mesh because in certain situations you can form a loop if you don't have a full mesh of IBGP sessions. So this is just an example here where you've got 4 routers in a line and some AS, and they've got router 1 has an eBGP session, router 4 has an eBGP session, and the IBGP sessions don't follow the topology. So router 2 has a session to R4, router 3 has a session to R1. So router 2 thinks the best path to some prefix is via R4. Router 3 thinks the best path to some that same prefix is via R1. So this is going to form a loop between them. Now this assumes that we're doing hop by hop routing. So actually, if you just add MPLS to this setup, it'll work because router 2 will put the label, the transport label for R4's loopback onto the traffic, and it will just go directly to R4. R3 is not doing a lookup; it's just doing MPLS forwarding action. But this is a situation, that we're having full IBGP mesh, or not having the full IBGP mesh can cause issues. So generally, we just kind of accept that, yeah, we need a full IBGP mesh because we want to have a full complete graph, a full picture of the full BGP topology of all BGP paths within the AS. Okay, so let's talk about. So we've accepted. Okay, we need this. This is why we need the full BGP mesh because BGP loop prevention within an AS is based on split horizon. So now we can say, okay, well, route reflection is the solution to the scalability issue of full IBGP mesh. So this is the RFC for route reflection. And I would actually, as a side note, recommend just reading through RFCs like this because you can see this RFC is actually quite short. Route reflection is actually a pretty simple function feature. Like we're on page 8 here, and now it's the acknowledgement. So it's like a 7-page RFC. It's not really that complex. And this section is the 2 path attributes that are added to do loop prevention. So the originator ID, which is just the router ID of the router that advertised that path to the route reflector. The route reflector is the one that adds this path attribute. So if that same client receives the path back to itself, it sees this router ID in the originator ID field and it drops the path. The cluster list is the second path attribute. And the cluster list is basically the same mechanism as AS path, but on like a route reflector cluster scale. So if the cluster list path attribute is not on the path yet, the route reflector adds this path attribute and it prepends its cluster ID. Whether or not the cluster list is there, it's always going to prepend its cluster ID. If it sees its cluster ID in the cluster list, it drops the path. This is the same thing as AS path loop prevention. The only other thing that you really need to understand about loop prevention that or maybe remember is that with what you need to understand with route reflection is that non-client to non-client routes are not reflected between each other. So a non-client to client is reflected, client to non-client is reflected, but non-client to non-client is not reflected. That's kind of really all there is to route reflection. So now let's talk about route reflection design considerations. So this right here is the most simple route reflection setup, I would say. You've got two fully separate route reflectors, and these are just purely control plane functionality. They're just implementing the route reflection functionality, and they're not in the forwarding path. They're not installing routes in their forwarding tables. These might be even like VMs that you're using for route reflection. And note that there's no peering session between these route reflectors. This might be totally fine because you just have two fully separate route reflectors. You've got the redundancy from the two route reflectors themselves. So in this case, the cluster ID is not really important. It's in a very specific case, you could say it is, because let's call this cluster 1 and cluster 2. Well, let's say this client here is misbehaving and it's reflecting routes when it shouldn't. So this client advertises a route, it's reflected to this client, and then this client is incorrectly reflecting it to this other route reflector. Well, if they have different cluster IDs, this will be accepted here. If they have the same cluster ID, this will actually be dropped right here. So the consideration of what you want the cluster IDs to be, you could say, is like, well, where do you want the loop to stop, the loop of routing information? Do you want to consider a path that's reflected by one route reflector and then gets received at the other route reflector? You want to consider that a loop, or do you want to consider it a loop when it gets back to that same route reflector? Either way, you're preventing the loops. You're just kind of you're catching more scenarios, maybe you could say, by having the same cluster ID. But overall, the cluster ID is not really an important consideration with two different route reflectors. But there is a redundancy issue here because they don't have a session between themselves. Let's say this session goes down, and then also this session goes down. So this client is going to advertise a path to this route reflector, but this route reflector doesn't have a session up anymore to this client over here. And if there's like a VRF between them for some customer, an L3 VPN VRF, that you've caused reachability issues. There's no reachability between those two PEs. However, this is quite an uncommon situation because IBGP is naturally multi-op, right? So it would be a strange situation where this router here still has reachability to this route reflector, but not this one, and yet this other client has reachability to the opposite, the other route reflector, but not this one. Generally, the failure situation you would see is just like the control plane has completely failed on this route reflector, and you've got this other one up for redundancy, and paths are reflected between clients, no problem. So it's kind of an unusual failure scenario, but it's a failure scenario that this design does not support. So let's talk about the case where we just add this BGP session between the two route reflectors. This is a little bit more of a common situation. It adds that redundancy in that case that we just looked at. But you have to make sure that to handle that case, that you have two separate cluster IDs on the route reflectors. Because if you have the same cluster ID, like cluster ID 1, cluster ID 1, this client advertises the path to both route reflectors. They're going to reflect it to each other. Now, this is whether they're configured as client or non-client sessions between the route reflectors. It doesn't matter because we're assuming that this right here is configured as a client. They're going to drop this route that's reflected between each other because they have the same cluster ID. So in that failure situation where we had this session down and this session down, this client is going to advertise a path to this route reflector. This route reflector is going to reflect it on to this one. If it's the same cluster ID, this is not going to be reflected back down to this client. This actually has to be a different cluster ID, maybe cluster 2. Now it's going to be reflected back down to the client. So having a different cluster ID adds redundancy. It handles that failure scenario, even though it might be unlikely. So you might choose that you don't want to handle that scenario. Well, what's the downside to having different cluster IDs? Well, having different cluster IDs increases memory usage on the route reflectors, because if they have the same cluster ID, you send a route from this PE or a client to these two route reflectors, they reflect it between themselves, but they drop that. So they're only holding one copy of every client's route. If you have a different cluster ID, they accept this reflection from the other route reflector, and now they have two copies of every client's route. So it increases memory usage, but it gives you more redundancy. Now, this memory usage argument or benefit, in my opinion, might not be that useful because no matter what, the clients are going to have two copies of every client's route. So what I mean is that let's say these are the same cluster ID because you want to optimize memory usage. So this client advertises a route. It's reflected between each other. They drop it because they're in the same cluster ID. But then these route reflectors advertise it to all of their clients. So every client is going to have two copies of the route, but the route reflectors are just going to have one copy. So you're optimizing memory on the route reflectors, but do the route reflectors have less memory than your clients? Because your clients are going to be holding more routes than the route reflectors in that case. So if your route reflectors can handle the same number of routes that your clients can, why not just use different cluster IDs and get the redundancy, you know? And there's a lot of arguments either way that you'll see online. And actually, from Ivan Peplniak's blog, he actually argues that the cluster ID is obsolete. He says that the cluster ID is useful in redundant route reflector situations where multiple route reflectors serve the same set of clients, but it can lead to partial connectivity when multiple IPG sessions are disrupted. That's the failure situation we just talked about. And he says that the revised route selection rules ensure that a route reflector in a cluster always prefers a route from a client. So what he's saying is that there's a rule in the path selection process that says to prefer the route with the shortest cluster list. So what he's saying is that when the route is reflected, this route reflector here is always going to prefer the path from the client instead of the path from the route reflector because the route reflector path is going to have a cluster list added. So you're never going to get a situation where this route reflector thinks the best path is actually the one that was reflected by the route reflector. It's always going to think the direct one is best from the client. That's what he's saying there. He says, because of this, it makes the cluster ID parameter obsolete. You should not use the cluster ID in new designs to increase the resilience of your network, meaning don't use cluster ID because by default, the cluster ID is just going to be the router ID. So don't use this command and set it to the same value on both the route reflectors. Just use the default, which is the router ID, and that way you increase resilience of your network. He's not really covering the memory optimization argument there, but yeah, what I typically have seen is that you just use different cluster IDs on the route reflectors to increase redundancy. However, the memory argument might be an important thing to consider if you're have the full internet table. Maybe you don't want the route reflectors to hold an extra copy of the full internet table for little benefit, just to handle the weird situation where these sessions are down between different route reflectors, right? It's a very uncommon failure situation. Okay, so now let's talk about the case where you've got two route reflectors, but they themselves are also PEs. So I just realized later that I didn't make it clear why you might have PEs that are also RRs. Well, the reason is that in some networks, it might not make financial sense to have separate routers that are only route reflectors. So you might have routers that are, have enough memory and CPU power to do route reflection. So it's just like a knob that you just turn on. It's free basically. You've already got these routers that can do this. So why not just turn it on these routers? So that's the reason why you run into this situation is that are you really going to buy another separate router, spend money on that, license it, upgrade it, and its only job is going to be route reflection? Why not just enable that functionality on a router that you already have, that you're already using? So you're kind of getting more of your money's worth, I guess. So yeah, that's why it's quite typical to run into this situation. So The considerations for cluster ID are really the same as before. That the same cluster ID optimizes memory, and different cluster IDs optimize resiliency or redundancy. But you might think, well, if I make the same cluster ID, cluster 1 and cluster 1, is this going to cause a problem for like VRFA routes for which this route reflector is acting as a PE when it advertises it to this other route reflector? The answer is no, because the route reflector only puts the cluster list and the originator ID path attributes on routes that it's reflecting. In this case, it's not reflecting those routes, it's acting as a PE. Same thing if it was just a regular eBGP session to a router on the internet. It's only it's only for routes that are reflected. So in that case, it will send the route for that it learns from this CE right here for VRFA, and it won't put the path attributes of the cluster ID and the originator ID. Now this route reflector will reflect it back to clients with the cluster list. This router will also advertise it directly to clients with no cluster list because that's a route that it's not reflecting. So each client will have 2 copies of the route, and the route reflector will only have 1 copy. We're going to talk about that problem coming up shortly. So yeah, when you have these 2 route reflectors here and they're also PEs, you can do the same cluster ID. It's the same consideration as before with what you set the cluster ID to. Okay, so now let's get into the problem situation. So when you have a session, when you have this setup where you have 2 route reflectors and are also PEs, you can't break this session because this route reflector only has 1 copy of the other route reflector's routes for VRFA here. So you have no redundancy there. This causes a problem for situations where you want to add an address family. And this is a very common situation because there's a lot of situations where you'll want to add an address family. Maybe you're running LDP-based VPLS and you want to do BGP auto discovery based VPLS. So you have to add L2VPN VPLS. Maybe you're migrating from VPLS to EVPN. So now you want to add L2VPN EVPN. Maybe a L3 VPN customer wants to add IPv6. So now you want to set up VPN v6. Maybe you want to migrate your IPv6 routing in the default table to 6PE. Maybe you want to add multicast VPN. Maybe an L3 VPN customer wants to add multicast. There's just a lot of situations where you need to add address families to your IBGP sessions. So, and this is a very dangerous thing because at least on Cisco, when you add an address family to the session, it'll just automatically reset your session and it won't ask you or it won't warn you. At least with when you change routing filters, you at least have to clear soft IBGP out or IP-BGP out, things like that. You have the control over resetting the session soft, or you can do a hard reset if you really want to. With the address family thing, it'll just reset the session and you're like, oh, wow, you just caused an outage. If you didn't know any better, you'd be like, oh, okay, yeah, I need to add an MVPN. I'll just go ahead and do that right now. I'll add MVPN on this router. This session will go down and you'll break connectivity between these 2 CEs for however long it takes for the BGP session to come back up. And I thought it'd be interesting just to take a look at why this is. Why does adding an address family cause the BGP session to renegotiate? Well, the reason is that any address family that's not IPv4 unicast, that includes IPv6 unicast, is a multi-protocol BGP. So even IPv6 unicast is multi-protocol BGP. And the 2 BGP speakers have to negotiate the address families that they support through the capability advertisement, which occurs in the open message. So in the capability advertisement, there's the AFI and SAFI, the AFI and SAFI it's sometimes called, which represents the address family that this BGP speaker supports for this session. I've also got a list of the SAFI values if you're interested. Generally, for AFI, it's either IPv4, which is 1, or IPv6, which is 2. And then the SAFIs are a lot of different values for like multicast, VPN v4, MVPN, things like that. So I've got another packet capture here from Nick Russo's collection, and this shows. Let's see. Okay, so in the open message is the capability negotiation, and so there's one capability parameter per address family. So here's IPv6 multicast VPN. Here's IPv4 multicast VPN. Here's IPv6 VPN v6. So you can see how every one of these address families is a different capability option, and this has to be negotiated in the open message. So when you add a new address family, you have to renegotiate BGP. And on a Cisco, at least, iOS 6E and iOS 6R, it's just going to automatically renegotiate that session for you. So let's go back to the RFCs, and actually there's a draft out for dynamic capability advertisement. So this would allow you to add a new capability to the BGP session without tearing it down. So to kind of make this even more clear, there might be a misconception that when you have different address families, those are different BGP sessions. So like if you have a BGP session between these, let's say these two RRs here, and you have it for VPN v4, VPN v6, L2 VPN, EVPN, you might think that, oh, those are three separate BGP sessions. No, that's not the case. They're all one BGP session, but on each of those on that one BGP session, you're supporting all those different address families. So that's why adding another address family, you have to tear down that whole session, and you break all those other address families you've got on that session. So this draft that's out would allow you to change capabilities between BGP speakers without having to tear down the session and bring it back up. As far as I know, it's not very widely supported. I haven't seen support for it on Cisco. So unfortunately, we're stuck with just having the session reset when we want to add a new address family. So now let's get to the design solution, which is having 3 route reflectors. So now, before, let's say we had, these 2 route reflectors here were in our previous design. Now we've got a third. So now we can break this session and have this third route reflector here reflect routes between the 2 route reflectors. So we've restored redundancy between the 2 route reflectors, which are also PEs. Now, the important thing about this design, though, is that now the cluster ID and whether you treat the route reflectors as clients or non-clients is important. It does make a difference. So if you'd used all the same cluster ID, if you do cluster ID 1, 1, and 1, now you don't have redundancy between the 2 RRs here. You break the session, it advertises a path. This route reflector creates the cluster list, it prepends its cluster ID to the cluster list, it reflects it onto this route reflector, and it sees, oh, my cluster ID isn't cluster list, I'm dropping it. So you don't have reachability between these 2 CEs here. So you do have to have different cluster IDs. The other thing is you do have to treat all of the route reflection sessions as client sessions, because if these are non-client sessions, the same problem or a similar problem happens where this route reflector advertises a route for, this learning from the CE. This route reflector says, okay, this is from a non-client. This session is also non-client. I'm not going to reflect it. So it's not reflected to that other route reflector. So it's very important in this design for this to work. You have to have different cluster IDs, which is the default. You just don't configure the BGP cluster ID command on Cisco, and you will have different cluster IDs by default. And you also must treat all the route reflector sessions as a client. So basically, every iBGP session you see here is a client session. There's no non-client sessions. So once that's set up, it's quite a simple design. And when you want to add an address family, now you can do it with no outage. So I'll just kind of step through the process that I would use because I thought it might be useful to somebody. So let's say you've got all these sessions up, you want to add an address family, and you want no impact. So the thing I would do is I would go into one route reflector, add the address family to all of these sessions here. So on iOS XR, I would have two different neighbor groups, or maybe just one neighbor group. I'd have a neighbor group for all of the clients, and then have just separate neighbors for these route reflectors. They wouldn't be in this neighbor group. So I'll just go into the neighbor group for the clients and add the address family. All the sessions are going to reset, but that's no problem because all the clients have two other route reflection sessions up. So no issue there. Next, I would go into all the clients and go into the neighbor statement for this one route reflector, route reflector number one right here, and add the address family to that session. The session is going to reset again and come up. So now you've got the new address family between route reflector one and all the clients. Now at this point, you can do both of these route reflectors at the same time because you do have redundancy through this first route reflector if you want, or you can just be safe and do one at a time for route reflector 2 and route reflector 3 and repeat the same process. Um, at this point for route reflector 2 and 3 on the clients, if you've got like a neighbor group, you can probably add the address family to the neighbor group, let both of those sessions reset, and you should test this out. But route reflector 1's session should stay up if you've got the address family configured under just that one neighbor. So I hope that made sense, but that's the way I would handle that. So then at that point, you'll have the new address family added to all of the client sessions, and all you have to do now is just add the address family to each of these sessions one by one between the two route reflectors, and that's it. And you'll have no loss of connectivity. And let's even talk about more specifically about what happens with the routing when you reset this session. So this router here will have two paths to this that the CE is advertising in VRFA. I'll have a path that's the best path directly from route reflector 2, and I'll also have a path via route reflector 3 that route reflector 3 reflected back to route reflector 1. So when you reset this session, you might wonder, is there going to be reachability, like a brief moment of reachability issues? It shouldn't be. It may be platform dependent, possibly, but there shouldn't be because even if you don't have BGP pick or anything like that configured, the next hop and the label information is not changing. All that's changing is whether you know the route directly from route reflector 2 or route reflector 3. So right now what's installed is the route via route reflector 2. This session breaks. At that moment, the forwarding information is still installed in the fib, right? And then BGP best path runs and says, okay, now I need to withdraw all those routes. And so now my best path is via route reflector 3. So now I'm going to update the fib, but the fib is the same. So in my opinion, there's no loss of traffic at all. It's different than doing pick, where you're changing to a different next hop. Okay, so I hope that all makes sense, but that's kind of an in-depth look at how this design works and allows you to have redundancy between the route reflectors, which are also PEs. So if you have a situation where your route reflectors are also have like eBGP paths or something, you might want to take a look at this because this could be kind of a hidden issue that you don't have redundancy between your two RRs. Now, what's the drawbacks to this? Well, the drawbacks is that you have this third BGP session on your clients for no reason, really. You don't need 3 copies of all routes. So if this is like the internet table, you now have 3 million routes instead of 2 million routes in the BGP rib. Like at least in the adjacency and rib, right? So that's really a drawback, is there's like too much redundancy there within the client's side. So an alternative to this might be to use hierarchical route reflection. So you can have layers of hierarchy, and each layer above treats the route reflectors below as clients, just as their clients. So there's no like specific hierarchical config. It's just the fact that the hierarchy above treats the hierarchy below as a client. So you can either have a permanent hierarchy where you have this hierarchy above that's reflecting routes between these two route reflectors here, or maybe you just add this during when you're making the change, when you want to add the address family and break this session. Although I would caution you, advise you to be cautious about this and think about this, because you're permanently, if you're in this situation here, that means this IBGP session has to stay up. If this breaks for any reason, you've broken reachability between these two CEs. So, really consider that there. But you might want to just add this as a hierarchy above just temporarily, and then you can do that without having to have a third session on these route reflector clients. Um, but this might be kind of tricky because in this situation, you're like a smaller service provider, and all your routers are being used as PEs already. So you might not have like some router out there that's like not used for forwarding or anything that you're just going to turn on route reflection. You could use like a VM as a route reflector. Um, I don't know if I would want to use a VM permanently as a route reflector, because there's some considerations there, like is there going to be any interoperability issues if you're using like a virtual route reflector for this open source or from a different vendor than the clients that you're using? Because even like between iOS XE and iOS XR, there's some even operability issues for like L2 VPN VPLS, where on XE you have to set the prefix length list to like 2 bytes, because iOS XR expects 2 bytes, but iOS XE by default will do 1 byte for the updates. Is like, if even between Cisco on XE and XR, there's some interoperability issues for BGP. I would imagine that there would be others for if you're using a VM as a route reflector from like some other vendor for this open source or things like that. So it's just another thing to consider and think about. Um, so yeah, but you could have some kind of permanent hierarchy here, and that way you've restored redundancy within the route reflector mesh, but you don't have the disadvantage of having three sessions on the route reflector clients. So yeah, I think that's all really to say about this design. I hope this has been something useful. As I started really looking into this, I realized, oh wow, there's no redundancy between my two RRs when they're acting as PEs. So just adding a third one just kind of magically or just automatically solves the problem without having to think about hierarchy and things like that. Maybe you only do this for like VPN slash VPN v4, VPN v6, L2 VPN, things like that, MVPN, which are not going to have the full internet table of routes. So if you have 10,000 routes, maybe 20,000 routes, having 3 copies of that versus 2 on the clients is not a big deal. So yeah, just these are all options. It's kind of interesting how we looked at the RFCs for route reflection. It's like, oh, the RFC for route reflection is like 8 pages. The RFC for multi-protocol BGP is also, what is this? Also 9 pages or something, 10 pages. The workings of them are not that complex, but yet the design considerations are where you can create all these combinations that all have trade-offs, and you really have to weigh the trade-offs and think about what's important to you to make the decision on how you want to design things like this. So yeah, I hope this has been useful. Let me know, in the comments if this is a problem that you've taken a look at and how you've solved this problem when you're using route reflectors that are also PEs.